recording? It's recording. Testing 1, 2, 3, 4. Testing 1, 2, 3, 4. Erase those stray marks. There we go. Okay, so this is 7-3. 7-3. And we're going to learn about multiplying radicals. So, do you guys know how to simplify square root of 9 times the square root of 4? Who knows what that answer is? What's the answer? What's the square root of 9? 3, right? This is equal to 3. What's the square root of 4? What's the square root of 4? 2. What's 3 times 2? 6, okay? Could I have done it like this? Could I have multiplied square root of 9 times the square root of 4 and get the square root of 36? What is the square root of 36? 6, okay? And so the answer is 6, okay? So either way you can do it. Well, put your phone away or I will take it away, all right? You come to the test and complain that you don't do well, and then while I'm teaching the first thing, you're on your cell phone, okay? So you too, Gia, put it away. I don't want to see it, Meadow. Put it away. Put it away, Ellie. No, I don't care. You're not looking at it. Okay. So, 6 and 6. So, it comes out to be 6. Yay, we're done. No, not quite. You can do the same thing with cube roots, okay? 27 cube roots. 8 cube root. What's the cube root of 27? Do you guys know? You know. 3. What's the cube root of 8? 2. What's 3 times 2? 6. The answer is always 6. No, it's not really. Okay? If you multiply, you can do this too. Square root of 27 times the square root of 8 comes out to be, I did this somewhere, 216. What do you think this cube root of 216 is? 6, okay? So that leads to the next rule, which you should probably write down. If you have a to the nth root times b to the nth root, this is equal to the nth root of a times b, okay? So you should write that down. Okay? This is important to know. So you can't add roots, but you can multiply. You can only add roots if they have the same base or the same root inside, which we'll talk about in a minute. Okay? So what if I had something like this? What if I had, where's my paper? What if I had the cube root of 2x times the cube root of 4x squared? Ooh, this is a good one. 4x squared. How would you do that? Oops, cube root. Sorry. Cube root. Multiply them together. If I multiply these together, what would I get? I get, what's 2 times 4? 8. So you'd have an 8 inside. What's x times x squared? X cubed. Then what I would do is, well, you don't have to do this, but you could separate it into 2 separate square cube roots, in this case. What's the cube root of 8? What's the cube root of x cubed? X. 2x. Isn't that weird? Okay? That's the final answer. Get that? See what I did? Got it? Okay. Do you need a drink to go with that? You're good? You're good to go?
I have one.
Oh, I was wondering if you needed to go to the concession stand or something. You're okay? All right. All right, then. So the next thing, what if I had something like this? 2 over a 5th root. times the B, BA, that's a B, BA over 3 fifth root. And they say simplify that expression, multiply those things together. What would you get? Just multiply the fractions together. What's 2 times B times A? 2BA. Okay? To be A or not to be A? That is the question. Okay. So what's 8 times 3? 3A. What cancels out? A goes away. It's a lucky day. You get 5, 2B, the fifth root of 2B over 3. And in that case, nothing else could come out of it, so you just leave it just like that. Okay? So if nothing else could be pulled out of the root, you just leave it. All right. Enough? We're not done yet. Enough! Well, that's an egg in France. Enough? Now every time I say that, I'm going to think about it. So this next thing is really, really important, okay? It's called simplifying radicals. Simplifying radicals, okay? So if you see, I think some of your calculators already do this for you, but you have to know how to do it by hand. The next quiz is going to be, if you want to use a 4-function calculator, you could use it, but I'm not going to let you use one of those scientific calculators because it does all the roots and stuff for you, and I don't want you to be able to do that, okay? So if I have the square root of 50, okay, you really have to learn how to do this for every class I teach, from geometry and I've taught up through calculus. You have to know how to simplify radicals because it's important to recognize patterns with triangles and numbers and things like that. So square root of 50, there's a perfect square inside the square root of 50. Do you know what that is? 25. So square root of 50 can be rewritten as 25 times the square root of 2. What is the square root of 25? 5, right? So I could leave this as 5 times the square root of 2. Simplifying radicals means take out any perfect roots that you can outside of the radical sign, okay? That's what that means. So how about square root of 18? Who can tell me how to do that? Square root of 18. Go ahead, Jessica. Right, that's equal to, you don't have to rewrite that square root of this times square, you could write it as 9 times 2, right? And what is the square root of 9? Go ahead, keep going. 3 times square root of 2. So you don't have to break, you could either do it like this, like I did here, or you could just leave it inside one square root sign and then take the square root of 3 outside. Okay? But to do that, you have to know what all the perfect square numbers are. Okay, so it's sometimes useful to make a list, like x, so x squared, x cubed. So if I have 2, what's 2 squared? 4. So you're looking for these numbers. Okay, what's next? 3 goes with 9, and what's 9 cubed? 27. 4 goes with 16. What's 4 cubed? Anyone know? 64. Okay. 5 goes with 25. We'll go up to 10. 125. 6 goes with 36. And 6 10. Did we say that's 216? 216. I don't know all these. 7, 49, and 343? No. Yeah, this, I was right. 343. 8, 64. 8 times 64 is 512. 9 is 81. And 729. And 10 is easy. 10 is 100. And 1,000. I would write these things down so you're kind of familiar, so you kind of know what you're looking for when you're writing. And for x to the fourth, I think we just go up a couple places. I don't think we even, so 2 to the fourth is 16, right? 3 to the fourth is 81. 4 to the fourth is, what is 4 to the fourth? 256, is that right? Is that right? Or 256. I guess you could do 5 to the fourth, 625. We'll stop with that, okay? We don't have to go any higher. Are you taking a picture of that? Okay. All right. So let's simplify some more radicals. So what about if I have, let's do, what if I have something like this? Simplify the radical, 40x squared. Square root of 40x squared. Meadow, wake up. What perfect square is in 40, Meadow? Which of these numbers is in 40? Which of these numbers is in 40? 4. Times what? 10. And what perfect square is in x squared? X, right? So I can pull out any perfect square numbers. What's the square root of 4? 2. And I can take out an x out of here times the square root of 10. Do you guys understand what I just did? Yes, Will.
So I had to get 4, but can you go like 5 or 6?
Because 5 and, because these are these numbers that you're trying to pull out. Perfect square numbers. Okay? You're trying to pull as much as you can outside of the radical.
Like you took pull 36 out of it.
Not out of 40. It has to multiply to that. Right?
Has to multiply to 40?
Yeah, it has to multiply. Okay? So, what if I had the cube root? Here we go. Cube root of 54. Cube root of 54. Calvin?
For the 41, why couldn't you pull out 8 and 5?
Because 8 is a perfect cube, because this says square root, not cube. If it was cube root, I would want to pull out an 8. But I'm not taking a cube root, I'm taking a square root. So I want this, I want numbers that I can take the square root of, right? Okay? So if I'm taking the cube root, I'm looking for these numbers. Which of those numbers, right? Which of those numbers is in 54? There is one. 27, right? 27 times 2 would give you 54. So I could rewrite this as the cube root of 27 times the cube root of 2. What is the cube root of 27? 3 times the cube root of 2. You kind of get that? Okay? So that's called simplifying the radical. What if I had one with a negative sign in front? Oh, here's a tricky one. Cube root of negative 16x to the 6th. X to the 6th. Who can tell me how I could break that down? Anyone? Not even just. Oh, Calvin can.
Would it be negative 8 and 2?
Yeah, negative 8 times 2.
Yeah.
Okay. Times the cube root of 2. How about the x to the 6th? Very good. What cube root is in x to the 6th? X to the third, right? So I could take out, have one x. How many x to the thirds do I have in there? I have 2 x to the thirds, right? Because x to the third times x to the third is x to the 6th. This is where it gets kind of tricky. So what's the cube root of negative 8? Negative 2. You could pull a negative 2 outside. You want to pull out everything that stays inside the box. You leave it at the end. What's the cube root of x cubed? What's the cube root of x cubed? X. What's the cube root of x cubed? X again. What? And this has to stay inside the box. You see that? So this becomes this. And then you could simplify this a little bit more. That's this cube root. This cube root is right there, right? That's cube root. So this becomes negative 2x squared cube root of 2. What? That's how it works. That's tricky. Tricky. A little tricky. But, so basically you want to try to pull as much as you can outside of the box. Should we try another one? Why don't you try another one? Let's try another one. Okay. I'm going to get rid of all this stuff. Because I want to leave these things. I want to leave these things here. How can I do that? Using my tools. What's this tool? Where's my toolbox? What happened? Toolbox. I'm going to erase all this stuff so that I can do another problem. Let's make a big eraser. Goodbye. Goodbye. Okay, so what if I wanted to do the fourth root of 810 x to the 9th. Whoa. Is there a fourth root inside of 810? No. 80, there's an 81 in there, because now I'm looking for fourth roots, right? So there's an 81 in there. So I could write this as the fourth root of 81, okay, times the fourth root of what? 81 times what gives you 110? 10. But then I have to do something with this x to the 9th. What's a fourth root? What fourth root is in x to the 9th that I can take outside of the box? X to the fourth. How many x to the fourths are in there? There's 2x to the fourth. So I'm going to take out 1x to the fourth, right? Like this. And then I'm going to take out another x to the fourth. I'm just rewriting it. I mean, when you get better at it, you don't have to do every single step. But there's one more x left inside the box. Do you understand that? Okay? Because it's x times x to the fourth times x to the fourth would give you x to the 9th, and it's the fourth root of it. So the fourth root of 81, right, is 3. So I could pull that outside of the box. The fourth root of x to the fourth is x. The fourth root of this x to the fourth is also x. And then everything that that can't come out of the box has to stay inside of the box. So I have a fourth root of 10 and an x, and those things both stay in the box. And then you can multiply those two x's together and get 3x squared fourth root 10x. That looks like 24, doesn't it? Let's fix that. Good.
Could you put the fourth root in front of the number so it doesn't look confusing?
Put the fourth root in front of the number.
Yeah, in front of the 3x
Put,
squared. Or
you don't usually do that because what happens is people put, like, it's hard to tell where the bracket ends, you know, so usually you put the number part before the square root part, okay, or the fourth root. Okay. Wow, teaching a long time. Okay, next thing, I'm going to give you some kind of work in a second, but multiplying radicals. So last example, we'll do 2 more examples and then we'll do it, okay? When you multiplying multiply and simplify. We already multiplied, okay? So if they say multiply and simplify, a lot of times you'll have things like this. 2 root of 3 times, you'll end up with something like this. 2 root of 3 times 3 root of 6. And I say, that can't be simplified anymore. But it can't. When you multiply these things, you multiply the numbers together and then you multiply the square roots together. What's 2 times 3? 6. What's root of 3 times root of 6? Root of 18. There's a perfect square inside of 18. What's a perfect square inside 18? 9. So I could rewrite this as, whoops, the 6 is in front, right? There's a 6 in front, times 9 times what? 2. Then I could pull this 9 outside of the box and turn it into what? 3. Okay, so I have 6 times 3 times the root of 2, which is equal to 18 root 2. Get what I just did? Right? You'll see that a lot. So I multiply the numbers together, I get this expression, and then I simplify the square root of 18 to 3 root 2, and then I multiply 6 times 3 root 2, which gives me 18 root 2. Okay? Now I'm going to introduce one with variables, and then we'll be kind of done. Okay? So say I had this, 3, 2x to the 5th times 4 times 10x squared. First thing I do is I multiply the numbers together. 3 times 4, Ian. What do I get?
12.
12. Then what do I get inside the box? Ian, keep going for me. What's inside the box? 20. X to the what? To the 7. Okay? Now I need to simplify what's inside the box. I have a 12. What perfect square is in 20? What perfect square is in 20? 4. Not 10 isn't a perfect square. 4 is a perfect square, right? 4 times what? 5. What perfect square? So instead of saying like x squared times x squared times x squared, I could write this as the square root of x to the 6th times the square root of x. Because what is the square root of x to the 6th? X to the 3rd. Because x to the 3rd times x to the 3rd gives you x to the 6th. You understand that? Okay? So I could have written the square root of x to the 7th as x squared times x squared times x squared times x, the square root of all that, okay? Square root of that is x, square root of that is x, square root of that is x. Or I could recognize that as x to the 6th, and the square root of x to the 6th is x to the 3rd, okay? Because it's x to the 6th to the 1/2 power. So then I take all my roots that I can. 12 times 2 times x to the 3, and the root of 5 and x has to stay inside the box. And then I multiply those two things together, and I get 24x cubed 5 root of 5x. Okay? There you go. A lot of steps, but it's kind of fun. I like these. Okay, so that's it. Your homework is on Schoology. You have some